In this video, we're going to look at the R formulas. We use the R formulas to change something in a form like this. So something sin x plus or minus something cos x, or something cos x plus or minus something sin x. So it's just in terms of sine or just in terms of cos. And we do that using the addition formulas, these here, which we're given in the formula book. So let's look at what we want to do. We want to change 3 sin x plus 4 cos x into the form r sin x plus alpha. So r sin x plus alpha must be equal to 3 sin x plus 4 cos x. And then we need to pick which of the addition formula we're using. So it's sine plus. So the sine plus formula is sine a plus b. So sine a plus b is sine a cos b plus cos a sine b. We don't want a's and b's though, we want x and alpha. So if we change the a's to x and change the b's to alpha, we almost have the same in the top and bottom. We just need to add this r. So we multiply each term by r, and now we have the same on the left side of both of these. Now we're going to compare. So we've got sin x and sin x here. So what's the difference between them? We've got r cos alpha on the bottom, and that is equal to 3. We've got 3 on the top, r cos alpha on the bottom, so r cos alpha must be 3. And the same for the next term. We've got cos x and cos x, but we've got r sin alpha on the bottom, and we've got 4 on the top. So r sin alpha must be 4. So now we've got two simultaneous equations. We'll call them 1 and 2. And we can solve to find r and alpha. So to find alpha first, we do the sine over the cos equation. So 2 divided by 1, r sine alpha over r cos alpha equals 4 over 3. The r's cancel out, and we've got sine over cos, which is tan alpha. So tan alpha equals 4/3. If we shift tan 4/3, making sure we're in radians, because the question said alpha between 0 and pi over 2. We get alpha to 3 decimal places, 3 significant figures, as 0.927. So there's alpha. How about r? There's a quick way and a long way. I'll show you the long way first, and then I'll tell you the quick way after. So if we square both sides of these equations, so r squared cos squared alpha equals 9, r squared sine squared alpha equals 16, and then we add the two equations together. So add the left sides together, r squared cos squared alpha plus r squared sine squared alpha equals 9 plus 16, 25. Factorize out the r squared, cos squared alpha plus sine squared alpha, and then we can change sine squared alpha plus cos squared alpha to 1 because of the identity that we've done in a previous video. So cos squared alpha plus sine squared alpha equals 1. So we're left with r squared equals 25. R equals the positive square root of 25, which is 5. So that was a long way. The quick way is to just take these two numbers, 3 and 4, square them, add them together, and square root. So we do Pythagoras on the two numbers, that we get in the question, so 3 and 4 in this case, square them, add them together, square root, and that gives us r. So we have finished. We know what r is 5, we know what alpha is, so 3 sine x plus 4 cos x can be written as 5 sine x plus 0.927. So here we've got express root 3 sine x plus root 6 cos x in the form r sine x plus alpha. So we need r sine x plus alpha to be equal to root 3 sine x plus root 6 cos x. So we're using the sine plus formula. So sine A plus B is sine A cos B plus cos A sine B. We're going to multiply through by r, and we're going to change A to x and B to alpha. So the left side equals the left side now, and we can compare the right side. So for this term, we have r cos alpha must be equal to root 3. And for the next term, if we take out the cos x, we've got r sine alpha equals root 6. To find alpha, we're going to do the sine over the cos. So equation 2 divide by equation 1. The r's cancel. We're left with tan alpha on the left, and we get root 6 over root 3 on the right. We could change that to root 2 if we wanted. Then we're going to shift tan. So shift tan root 2, or shift tan root 6 over root 3. To 3 significant figures, we get 0.955. To find r, we're going to use Pythagoras. So the square root of root 3 squared plus root 6 squared. So the square root of 3 plus 6, root 9 is 3. So we have r 3 sine x plus 0.955. So we can express root 3 sine x plus root 6 cos x as 3 sine x plus 0.955. And now we're going to use that to solve an equation. So we can change this root 3 sine x plus root 6 cos x to 3 sine x plus 0.955. So we divide both sides by 3. Sine x plus 0.955 is now equal to 2/3. Shift sign, so shift sign 2/3. And we get the first answer of 0.729727656. I'm going to write down the whole number because we're going to have to subtract 0.955 from all the answers, and we need them to be between 0 and 2 pi. So we'll leave that answer there for now. We're going to do pi minus that answer to get the second answer. So 2.41864997. Because we're going to subtract 0.955 from the answers, the first answer we got is going to be no good to us. It's going to go below 0. So we need to add 2 pi onto it. So we add 2 pi onto the first answer, and we get 7.012912963. Now we're going to subtract the 0.955 from our answers. So for the last one, to 2 decimal places, we get 6.06. And for the 2.411 answer, we get 1.46. And those are the 2 answers between 0 and 2 pi. Okay, here we've got express 12 cos x plus 5 sin x in the form r cos x minus alpha. So we want r cos x minus alpha to be equal to 12 cos x plus 5 sin x. So we're using the cos minus formula. So cos A minus B, which is cos A cos B plus sin A sin B. We're going to change the A's to X's, the B's to alphas, and multiply through by R. So the left side of the top and the bottom are identical. Then we're going to compare the right sides. So we have R cos alpha must be 12 from this term. So R cos alpha is 12, and R sin alpha must be 5. To find alpha, we're going to do sine over cos. So tan alpha is 5/12, and we shift tan 5/12, which gives us alpha as 0.395 to 3 significant figures. To find r, we're going to do Pythagoras, so 12 squared plus 5 squared square rooted, which is 13. So that means we have 13 cos x minus 0.395, and that's our answer. Hence, find the minimum value of 12 cos x plus 5 sin x, and the smallest positive value of x for which it occurs. So the maximum value of the cos wave is normally 1, positive 1. But in this case, we've got 13 times the cos function. So 13 times bigger, it's multiplied by 13. So the maximum is now at 13. So the maximum is at 13. If we were asked for the minimum, that would be at negative 13. And where does it occur? So we want to know where this function, 13 cos x minus 0.395, is equal to 13. So where is, if we divide both sides by 13, where is cos x minus 0.395 equal to 1? So if we shift cos 1, we should get 0, because the cos graph is equal to 1 at 0, and add 0.395 to both sides, we find out that this maximum occurs when x is 0.395, and you could substitute it back in to check, and that's our answer. Okay, you can try pausing the video and giving this one a go, or carry on watching and I'll go through the answer. So we've got to express 8 cos x minus 6 sin x in the form r cos x plus alpha. So r cos x plus alpha is equal to 8 cos x minus 6 sin x. So we're going to use the cos plus formula. So cos A plus B which is cos A cos B minus sine A sine B. We're going to change the A's to X's, B's to alphas, and multiply through by R. So then we'll compare the top to the bottom, which gives us R cos alpha is 8 and R sine alpha is 6. To find alpha, we're going to do sine over cos. So tan alpha is 6/8. We're going to shift tan 6/8. So alpha equals 0.644 to 3 significant figures. To find R, we're going to do Pythagoras. So the square root of 8 squared plus 6 squared, which is 10. So we have 10 cos x plus 0.644. Hence, find the minimum value of 8 cos x minus 6 sin x and the smallest positive value for x for which it occurs. So the minimum value of 10 cos x plus 0.644. So usually the minimum value is -1. This is multiplied by 10. So the minimum value is now -10. -10. And the smallest positive value for x for which it occurs. So when is 10 cos x plus 0.644 equal to -10? So where is cos x plus 0.644 equal to -1? So where is cos -1? That is at pi radians. So if we shift cos -1, we should get pi. And then we're going to subtract 0.644. And we get x at 2.50 to 3 significant figures. Okay, here's another question. You can pause the video again, give this one a go, or carry on watching and I'll go through it. We want R sine x minus alpha, and the original is √5 sine x minus √11 cos x. So it's sine minus, so we're using sine A minus B. And that original formula, sine A cos B minus cos A sine B. Change A to X, change B to alpha, and multiply through by R. So comparing the top and the bottom, we get R cos alpha is √5 and R sine alpha is √11. So to find alpha, we do sine over cos. So tan alpha is √11 over √5. So shift tan √11 over √5, and we get alpha as 0.978 to 3 significant figures. To find R, we're going to use Pythagoras. So the square root of √5 squared plus √11 squared, so √16, which is 4. So we have 4 sine x minus 0.978. And we're going to use that to solve the equation. So we've got 4 sine x minus 0.978 equals 3. We divide both sides by 4. So sine x minus 0.978 equals 3/4. I'm going to shift sign 3/4, which gives us x minus 0.978 is equal to 0.848. Yep, that's the three significant figures. And we're going to do pi minus answer because we're in sine, 2.29. And we need to add 0.978 onto those answers. If we add that on, they'll both stay between 0 and 2 pi, so they are the answers that we want. Plus 0.978, so we get 1.83 and 3.27.